For this week, I'm just going to look at simple non-enzymatic browning. And so to do that, I cut a potato in half and then I heated it in two different ways. The first way that I heated it was by boiling, and this potato reached a temperature of 212 degrees Fahrenheit because that's the temperature that water boils at. And it actually cooked through quite nicely. As you can see though, besides some bruises on the potato, there's no discoloration, there's no browning that occurred. And one of the main reasons that occurred was because at only 212 degrees Fahrenheit, the temperatures were not reached for the sugars and the proteins to react. Those reactions occur between 220 and 350 degrees Fahrenheit, depending on the sugar involved. The second way that I heated the potato, the second half, was by putting it under the broiler so that it heated very high, and as you can see, it got a little burnt because I got a little impatient. But the reactions that occurred here did occur at the high enough temperatures for linkages to form between the sugars and the amino acids in the proteins. Now, if just sugars began to link, then the potato would have caramelized. Now, there's one main way that I can tell that this wasn't the case and that actually Maillard reactions occurred, and that is because of the aromatics, especially because I burned it a little bit. It's quite odoriferous, and it has a kind of rich smell, and that odor is released when the amino acids in the proteins and the sugars link. And what also occurs when those links occur is this golden brown coloring. Now, there's no way to tell what the byproducts of these reactions were because there are many different sugars and many different amino acids that can form links, and it also depends on the temperature that you heat it at and for how long you heat it, what types of byproducts you form. There are hundreds of possibilities. And that, in a nutshell, is the importance of the Maillard reaction, and I'll just hold up for you the different potatoes again. Thanks!